All right, the same kind of deal is going to happen with these problems as when we were finding the area. I do expect you to be able to graph some basics here, okay? So we are going to let R be the region bounded by this curve, which is x plus 1 squared, the x-axis, and the two vertical lines, x equals 0 and x equals 2. We want to find the volume revolved about the x-axis. So I know I'm going from 0 to 2. That is also going to help us with our graphing. So I'm going to squeeze this in. I should have made the graph here also when I was doing the other stuff. But I know I am stopping here. I'm going to make this, because I've got to revolve around that axis, I want to make sure I have plenty of space. All right. So I should be good there. Let's see. I know I'm going from 0 to 2. So this, pretend like I actually did a good job with that. Well, no, let's come back. I'm going to try to be a little bit better with my drawing here. So I'm at 0, 1, 2, right? So I'm going to go from 0 to 2, so I don't need a whole lot that way. And I shouldn't need any to the left, so that wasn't even me thinking, was it? Okay, so the question here is I have the point, or pardon me, I have the graph of x plus 1. So if I'm going to plug a 0 in here, what's 1 squared? 1. So there is my dot. If I plug a 1 in here, what's 1 plus 1 squared? So 2 squared is 4. 2, 3, 4. I have that point. And then 2 plus 1 is 3 squared, which is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, man, like a doggone glove, right? So here is my graph. We know it's a parabola, but I'm only going to that value. This is not a parabola that goes on forever and ever. I don't care about any other points that we're looking at. Those are the only points that I care about because I am stopping this at my vertical line at 0 and my vertical line at 2. And so this is bounded by the x-axis. So that tells me, I'm going to zoom in a little bit just so I can see this. Oh, dang. Oh my, sorry. So I can see this a little bit better. Zoop. Okay, I am taking this shaded region and I'm going to revolve it about that x-axis. So that means as I'm looking at this, I am revolving this about the x-axis. So let's see. If this is up here at 9, I know I'm going to hit this right here at 1, 2, 3, 4, 5, 6, 7, 8, 9. So down here, my bottom is going to be about right here at 9. So as I'm swinging this bad boy right on around, see, I told you I'm not so good at this, so just hang in there with me. I'm going to go color on it. So this is going to kind of come down like this. And then I have, oops, not any higher. Try again. So this is going to go down, swing around, and kind of back up. Kind of. Let me try one more time. It's, if I'm looking at this, I don't know, kind of like that, right? Where I'm swinging this around, you kind of get the idea. And I've got this shaded figure, my whole line here of x equals 2 knocks that off. But this is going to be this circle at the end of it. That's the moral of the story. So my radius of my circle is going to be all of these heights of my function. And I'm going from 0 to 2. So this is a circle. What's the area of a circle? Pi r squared. So that is going to help me whenever I make my integration. My volume here is going to go from 0 to 2 of pi. My radius is the height of my function. So that's where I'm going to get x plus 1 squared. That's my actual function. and I square that. X plus 1 squared is my f of x, and then I square that. All right. Now, if I have power to a power, what is that? Yep, you multiply. So, okay, so here's the other thing I'm going to do, and I'm just going to shortcut this down here a little bit for us. Pi is a number, and pi is a pain, right? If I'm trying to mess with that or deal with it. So because this is just a number, you can take that and chuck it out front whenever you have that integration. So I don't want to mess with pi. So I'm just going to chuck that fella right in front, and I actually have x plus 1 to the 4th dx. You see what happened? And I'm not going to go through and try to multiply that out. That's nuts. So because I'm not going to try to go through and multiply that out, I'm going to do a little u sub. So if you do a u sub, you can do that. Honestly, you know the du is going to equal the dx. So I'm okay if you don't. But you can also do the u sub, honestly. Either way. So my u here is going to be x plus 1. My du is going to be a dx. And because it's a du dx situation, you could skip it, because we've talked about that before, but we're just going to go with it. So x equals 2. If I plug in the 2, 2 plus 1 is 3. At x equals 0, 0 plus 1 is 1. So I am actually integrating my volume here of pi. I'm going from 1 to 3 of u to the 4th du. And that's what makes it just easier. So I don't have to mess with all that stuff. Just play that out. So pi is just a number, so I'm still going to have pi, but now I have a 1/5 u to the 5th, and I'm taking that from 1 to 3. And either way, I'm probably just going to leave that pi over 5 and just put that in there, because it's going to be that common denominator then. So I've got pi over 5, 3 to the 5th, minus pi over 5, 1 to the 5th. Now what's 3 to the 5th? Oh, that's a good question. 3 to the 5th. Well, you got 81 times 81, and then times 3. So we can do something like that. Oh, 3 to the 5th. 243. It just dawned on me. Now, that's not a common one, so I don't know that I'm going to give you something like 3 to the 5th, but honestly, that'd be an easy one to figure out. It's just 81 times 81, right? And then when you multiply that out, then you take that times 3, because here's 2, 2, so there's 4 of them, and then you've got one more. But you do get 243. Just like 2 to the 5th is 32. That's one that you probably do know already. But 243, it just dawned on me. All right, minus pi over 5. So I've got a common denominator. So volume is 242 pi's over 5. And we're going to leave it in terms of pi. And the other thing is we don't have any units on this. So if we had units, we would cube that unit. But we don't have any units, so just keep up with what we have here. I'll squeeze this in. So the volume of this whole solid, like this, I don't even know what you would say that looked like, right? It's this flat piece right here, and it kind of goes out like a filled-in bowl almost if you looked at it from the side. All right? Okay, see, not so bad at all. Not bad at all. Pardon me, using the formula, you can pull that off, and then it's just that basic integration. It's no big deal.